An equation is a mathematical sentence containing an equal sign. Equations can either be true, false, or an open sentence. Here are three examples. 5 times 7 equals 35 is an example of an equation that is true. 13 minus 8 equals 6 is an example of an equation that is false, because 13 minus 8 actually equals 5. And finally, x plus 15 equals 20 is an example of an equation that we would call an open sentence, meaning that the equation could either be true or false depending on the value of the variable x. A solution of an equation is a value for the variable that makes the equation true. And to solve an equation simply means to find all of the solutions. Equations that have the same solution sets are called equivalent equations. Take a look at the 5 examples on the board. Which of the following equations are equivalent? To determine this, we must find the solution sets of each one of these equations. Our only solution to x plus 3 equals 10 is 7, because 7 plus 3 equals 10. Our solution for our next equation, again, is 7, because 7 minus 2 equals 5. For x equals 28, our solution is 7. For x squared equals 49, we see that our solution could be 7 again, because 7 squared equals 49. However, another potential solution, another solution is -7, because -7 squared also equals 49 when we evaluate the equation. This means that our solution set has two solutions, 7 and -7. Finally, our last equation, which is likely the simplest of them all, x equals 7, our solution is 7. Here we see, with these 5 equations, 4 of them are equivalent. The outlier, x squared equals 49, is not equivalent because it has a separate solution set that contains 2 solutions that are different than the one solution that we found in the other 4. This is relevant because the process of solving equations is basically this. You simply continue writing simpler equivalent equations until you find an equation for which the solution set is obvious. Our formal definition of solving linear equations states that you must use the addition and multiplication properties of equality to write equivalent equations until the variable is isolated. Let's take a look at the addition and multiplication properties. The addition property states that for any real numbers a, b, and c, a equals b is equivalent to the equation a plus c equals b plus c. Essentially, the same number can be added or subtracted on both sides of an equation without changing the solution set. The multiplication property of equality states that for any real numbers a, b, and c, where c does not equal 0, a equals b is equivalent to a times c equals b times c. This rule essentially states that the same non-zero number can be multiplied or divided on both sides of an equation without changing the solution set. Let's practice the addition and multiplication properties. Solve each equation and write the solution set. We often call this isolating the variable. For example 1, To isolate our x variable, we must do the inverse of add 17 and subtract 17 on both sides of the equation to isolate our variable. And we'll write the equivalent equation, x equals -9. Here, we see that -9 is our solution to our equation. For example 2, y minus 2.5 equals 1.6. We add 2.5 to both sides of the equation to isolate our y variable, using again the addition principle, resulting in the equation y equals 4.1, and we see that that will be our solution, 4.1. In example 3, where -3 is being multiplied with a, in order to isolate our variable a, we must do the inverse of multiplication to isolate the variable, which is division. So we divide both sides of our equation by -3. When we do this, we see that -3 divided by -3 will cancel each other out, resulting in a equals -8. Here we see clearly that our solution will be -8. And in example 4, where we are dealing with a fraction, we see that 3 over 4n equals 9. To isolate our variable n, we must multiply both sides of our equation by the reciprocal of 3 over 4, which is 4 over 3. In doing this, we see that on the left side of our equation, our two fractions will cancel each other, resulting in 1n. And on the right side of our equation, when we reduce our fractions and multiply, we see that n will equal 12, which is our solution. Pause the video at this time and practice these 4 examples of solving equations on your own. Let's check our answers quickly together. For number 1, we subtract 12 on both sides, resulting in x equals -19. So our solution is -19. Number 2, we add 2 over 3 to both sides, resulting in y equals -5 over 6 plus, using common denominators, 4 over 6, and we see that our solution will be -1 over 6. For number 3, we divide by 9 on both sides. So our solution for a and the equation is 5. And number 4, again, we will multiply by the reciprocal, isolating our variable n and setting that equal now, when we cancel our fractions, to 16.